Hi guys, my name is Lane. I'm from team 4441W. Today I'll be teaching you the basics of programming for VEX. Hi, my name is Lane from team 4441W. I'll be teaching you on the basics of C++ VEX V5 programming. Programming is giving instructions to the robot so it knows what to do. Programs are all around us every day and everywhere. For example, our phones, our laptops, even our cars. There's plenty of programming languages, but for VEX V5, we use programming to control our robot to do tasks for us. To do this, we use a programming language called C++. There are many types of programming languages, and each is used for something else. Some, like Python, are easy to learn and are used for simple programs and data. Others, like C++, are used in robotics and engineering. The language you use is based on what you're trying to do. What we're using is in fact C++. It's the language we use and how we tell the robot what we want to do. You can think of it like giving very clear instructions to someone. If the instructions are good, then the robot works well, but if the instructions are bad, it will mess up. In C++, we use ideas called variables, which store values and names. The main types of variables are integers, called int for short, float, and booleans, called bool for short. Integers, or int, store whole numbers. To do this in C++, do like this. This stores the value of the whole number 100 and the word speed. You can access it by referencing it by saying the word speed. Notice how there's a semicolon at the end of this line. This shows that the line is complete. Most every line will always need a semicolon at the end. This would print out the value 100. As the value of the speed is 100, the next type of variables are floats. Floats are just like integers, but they use decimals. 5.0 is a float, while 5 is an integer. These two things are the same, but are different values. You can use a float by accessing it like this. This value is storing a float in a distance variable, so the value of distance is 4.2. The next variable type are booleans. These are true and false values. These values store the word active as true and store the word lazy as false. You use this when you want to toggle between two options like on or off, yes or no, true or false. For example, if a button is pressed, you can set a boolean to true, and if it's not pressed, it's false. This helps the robot make a decision. A toggle is when you press a button once to switch something on and press it again to switch it off. Instead of it holding a button, it flips between true or false every time you press it. This is useful for things like pistons or intakes. Here's a simple toggle example. This checks when the button is pressed first and flips the value of toggled. The function controller1.button_a.pressing checks if button A on the controller is currently being pressed and returns true or false if it isn't. Boolean operators are what helps make the robot actually make decisions instead of just doing the same thing over and over. The main ones are and. You can reference this by using ampersand sign, or by using the line feature on your keyboard twice, not with the exclamation mark. Use these when you want to check for multiple conditions. For example, if you only want the robot to move when two buttons are pressed, you can check this by. This means the robot will only move if button A and button B are being pressed at the same time. If only one button is pressed, nothing happens. This means both things have to be true. In real life, it's like saying, I'll go outside if it's not raining and I finished my homework. Both have to be true or you don't go. The or operator means that only one has to be true and not just flips a value. So if something is true, exclamation mark makes it false. Another really important thing in programming is loops. Loops let the robot repeat actions without you writing the same code over and over again. One common loop is a while loop. A while loop keeps running as long as its condition is true. Since true is always true, this runs forever, which is actually what you want for driver control because you want the robot to always be checking for input. You can always use a for loop when you want something to repeat a set number of times. This starts I at 0, keeps going for while I is less than 10, and adds 1 to I each time. Think of it like counting reps at the gym. You'll do a set number of times, then stop. To use a motor, you create one like this. This creates a motor on port 1. The false just means it's not reversed. To make it spin, That spins it forward at 80% speed. There are different ways for the robot can stop depending on the braking type. Coast lets the motor roll to and stop naturally. Brake slows it down faster by resisting motion. And hold locks the motor in place and keeps it from moving. To stop it, you can do one of these. If you have multiple motors on the same side of the robot, you can group them together so you only have to control them once. Now, left side controls both motors at the same time. You spin and stop it the exact same way as a single motor. Pistons are even simpler. You just set them to true or false. True extends it, false retracts it. You can hook this up to a button and use a boolean to toggle it on and off, which is exactly what that type of bool variable type is useful for. VEX has its own library, which is just a little collection of pre-written code that lets you control the robot's hardware, instead of having to figure out how to talk to the robot from scratch. VEX already wrote that code. You just use it. In a VEX match, there are 2 periods. The first is autonomous, which lasts 15 seconds. During this time, the robot completely runs on its own with no driver input. Whatever you programmed it to do, that's what it does. This is why autonomous accuracy matters so much. You only get 15 seconds and every point counts. After that comes driver control, which lasts 1 minute and 45 seconds. This is where the driver takes over and controls the robot manually with the controller. Your driver control has to be ready to go to the second autonomous end. Autonomous skills is a skills match where the robot runs on its own for 1 minute with no driver controlling it. There are no other robots on the field, so you can program a longer, complex routine to score as many points as possible. Driver skills is a skills match where a driver uses the controller for 1 minute to score points manually. Your skills ranking at a tournament is based on the best autonomous score plus best driver score. The higher your combined score, the higher your team ranks. This is why autonomous code has to be really good. In a tournament match, the autonomous period lasts only 15 seconds, so every action has to be precise. In autonomous skills, the robot runs for 1 full minute, giving you more time to score points with a longer program. To make autonomous actually reliable, teams use PID and odometry. PID stands for proportional integral derivative. It's a system that constantly checks how far the robot is from its target and adjusts the motor speed to get there accurately, instead of just running the motors at full speed and stopping. PID slows the robots down to get as close as possible so it doesn't overshoot. It needs an inertial sensor to work. Odometry takes it a step further. It uses tracking wheels, which are unpowered wheels with encoders on them, to calculate the robot's exact position at all times, instead of telling the robot to drive for 2 seconds. You can tell it to drive to a specific coordinate on the field. Combined with PID, this makes autonomous extremely precise. It needs tracking wheels and an inertial sensor. Together, PID and odometry are what separate a basic autonomous from a really competitive one.